4-5, sequences. Sequences just mean patterns, but there's two kinds of sequences. There's arithmetic sequences and there's geometric sequences. Arithmetic, geometric. Here's the difference. Arithmetic sequences is when you're adding or subtracting to get to the next number. Geometric sequences is when you're multiplying or dividing to get to the next number. So let's look at these two sequences. This one is going 2, 4, 6, 8. So what's happening to get to 4 from 2? Well, if you said they're adding 2, you're right. Look, that's plus 2 to get there. Plus 2, plus 2. So what kind of a sequence is this? This is an arithmetic sequence. Exactly. And could you find the next number? Well, sure. Couldn't you go plus 2 and find out that 10 comes next? And plus 2 and 12 comes next? And plus 2 and 14 comes next? You could do both things. You could say it's arithmetic, and you could find the next numbers. The second sequence, what in the world is happening to get from 7 to 21? From 7 to negative 21. It's multiplying by negative 3. So times negative 3, that looks like x minus 3 to me, times negative 3, times negative 3. So what kind of a sequence is this? It's a geometric sequence, because geometric sequences have to do with multiplying and dividing to get to the next number. Could you find the next numbers? Well, sure. You would take negative 189 and multiply by negative 3. A negative times a negative, it's going to go positive. 3 times 9 is 27. 3 times 8 is 24 plus 2 is 26. 3 times 1 is 3 plus 2 is 5, so it would be positive 567. Now, this is another way to write a sequence. This top row is saying what number of term it is. In other words, this is the first term, the second term, the third term. It's labeling the terms. So the first term in the sequence is negative 12. The second term in the sequence is negative 5. The third term in the sequence is 2. The fourth term is 9. It's just the same as if I had written them down like this with commas. Because obviously this is the first term, right? Second term, third term, fourth term. That's all in the world that this top line means, is what term it is. So, the first thing to ask yourself is this an arithmetic sequence or a geometric sequence? And remember, the way to find out is, how am I getting from here to here? How am I getting from here to here? What's happening? Okay? Well, what's happening in this sequence is that you're going plus 7. Negative 12 plus 7 is negative 5. Negative 5 plus 7 is 2. 2 plus 7 is 9. So what kind of sequence is this? Right, this is an arithmetic sequence, because arithmetic sequences are only adding and subtracting. Now, could I find these two missing terms in this sequence? Sure. 9 plus 7 is 16. And 16 plus 7 is 23, so I could do that. Okay, here's another sequence. Remember, the top thing is just saying the first term, the second term, the third term. We're concentrating on these numbers here. How can I get from 4 to negative 12? And how can I get from negative 12 to 36? How can I get from 36 to negative 108? That's what we're trying to figure out. Well, 4 times negative 3 would give me negative 12, wouldn't it? And negative 12 times negative 3 would give me positive 36. And 36 times negative 3 would give me negative 108. So, what kind of a sequence is it? Arithmetic or geometric? Well, it's geometric because when you're multiplying or dividing to get the next term, you're a geometric sequence. Now, could we find the missing term? Well, sure. We could go negative 108 times negative 3. A negative times a negative, it's going to go positive. 3 times 8 is 24. 3 times 0 is 0 plus 2 is 2. 3 times 1 is 3. So it's going to be positive 324. Now, the next kind of problem that happens with this lesson on sequences has some very specific directions. In fact, if you don't learn what the directions are that go with this problem, you're going to have a hard time doing it. Because the only way to know what to do on this problem is to know what the directions mean. So, it says write a function that describes each sequence. Well, first of all, a function is a fancy word that means equation. So we're going to be writing an equation. Now, not every equation is a function, but the ones we're going to use are. So you just need to say to yourself, oh, I have to write an equation. I'm going to write an equation. An equation has an equal sign. All equations have equal signs. Okay? We're going to write an equation that goes with this function. And here's how we're going to do it. Every time you see these directions, you've almost got to memorize these directions because you've got to know that these directions go with this thing. When you see these directions, you're going to make an input-output table. Remember input-output tables? So, you see these directions? You draw your table like this. Okay? And remember, this is Y. Now, the book, since this is a sequence, likes to use N instead of X. It's perfectly fine with me if you use X. But don't be surprised when the book uses N here. So if you want to use N there, that's fine. Or you can use X. Now, the thing about this input-output table is kind of weird. We don't know the rule yet, because that's actually what we're going to find, because the rule is part of the equation. So, here's what you need to know. Remember in the little charts we had right before this, how it was always first term, second term, third term? That's what's going to happen on X. It's going to happen the same way. First term, second term, third term, fourth term. X or N is always going to mean the first term. Well, here's the first term, the second term, the third term, the fourth term. So, you're always going to put 1, 2, 3, 4 here. You're going to start with 1 and go however far you need. We have 4 numbers, so I went to 4. Now, the Y values are these. These are Y values. So we're going to put these numbers in the Y. Let me draw my lines. Okay, so 2, 4, 6, and 8. Now, this is a little bit different than what we did before, because to find the equation, we have to figure out how we're getting from here to here, and how we're getting from here to here. Are we adding something? Are we multiplying by something? How are we going from 1 to 2? How are we going from 2 to 4? How are we going from 3 to 6? Are we adding something, multiplying something, 4 to 8? This one is pretty easy to see what's happening. It's got to be the same thing every time. So, if you are thinking, well, Miss Stephan, if you multiply 1 by 2, you get 2. And if you multiply 2 by 2, you get 4. So, what's happening here is x times 2. 1 times 2 is 2. X times 2. 2 times 2 is 4. Okay? So that's what's happening. You could go ahead and put the numbers in. You could say 1 times 2 is 2. 2 times 2, you're using these numbers. How about the next one? 3 times 2, is that 6? 4 times 2, is that 8? Yes, so we're multiplying the x by 2. So that means the rule would be x times 2. Now, in algebra, you don't usually write x times 2 to show times 2. You usually write 2x, don't you? Okay, so at the very end of this, what we do now is we always put y equals, and then we take the rule and put it on this side. Now, is this an equation? Yes. And this is the answer to this problem. Let's do another one. Okay, here's another problem. Notice I wrote the directions again because these directions have got to stick in your head. And remember, function means equation. So when you see these directions and a list that looks like a sequence, you know the first thing you're going to do is make an input-output table every time. Okay? And what else do you know? You know that you're going to have x and y, and you're going to have 1, 2, 3, 4 for x. How do I know that? Because this is the first term, the second term, third term, fourth term, and that's what x is. Then these numbers that they gave us in the problem go in the y's. 4, 5, 6, 7. And then we start asking ourselves, how can we get from 1 to 4? How can we get from 2 to 5? How can we get from 3 to 6? How could we get from 4 to 7? And it's usually times something or plus something or minus something. So you have to be thinking like that. Well, I'm looking at this and I'm going, oh, that looks like 1 plus 3. And this looks like 2 plus 3. This looks like 3 plus 3. Let's try that out. So, 1 plus 3, that's 4. Then I have 2 plus 3, that's 5. Then I have 3 plus 3, that's 6. And 4 plus 3, that's 7. So what does that make the rule? Well, that makes the rule x, whatever your x is, plus 3. Now we're ready to write our equation. Our equation's always going to start with y. So y equals, and then we're always going to put the rule on this side, x plus 3. This is your answer. Okay, here's your first part of video homework. Here's the second part of video homework. Remember, this is the one where you start with an input-output table. Don't forget that. Have a lovely evening.